Assalamu alaikum warahmatullahi wabarakatuh. My name is Hussein Basourrah, and this is my individual project for course EE 472. And my topic will be acoustic output measurement for ultrasound. And this is my agenda: introduction and history and scanning system and categorize measurements, and finally the references. So let's go first with the introduction. The parameter to be reported under diagnostic ultrasound guidelines are the frequency and the bandwidth, and the peak positive pressure, peak reflectional pressure, team overall average intensity, pulse average intensity, mechanical index, and the thermal index. The parameter to be reported under ECWL guidelines are the peak positive pressure, peak reflectional pressure, rise time, and compressional pulse for describing the shock front. Focus geometry, acoustic, the pulse energy, and target accuracy. All measurements were made using hydroponics. So now I'm going to talk about the history. A fiber optic hydroponics was used for the acoustic output. The FOBH is capable of withstanding the greater pressures associated with higher amplitude acoustic pulse without compromising the bandwidth. Thought that the discrete sensitivity requires more signal averaging to improve SNR. An Algine scope Santa was substituted for the partial measurement for the combination of bandwidth, sequential acquisition mode, the large memory. The scanning system. The custom in-house scanning system for diagnostic output measurement included a polyvinyl fluoride. A custom fixture allows the probe to be titled in three independent axes: pitch and yaw and roll. For setting the imaging plan parallel with YZ plan, the motion stage. The hydrophony is mounted to an arm which is connected to the 3-axis sensor system. The tank is filled with the room temperature diagnosed water. The water is dosed using a custom in-house portable dosing system. So the categories of measurement, there are 3 categories for measurement I will explain. First of all, coupled point measurement, hydrophonic measurement of pressure, intensity, and associated parameter for medical transducer, the mechanical index and the thermal index. And tissue attenuation pressure and intensity parameter can be calculated. Measurement of transmitter and receive voltage response are often also computed for underwater sonar transducer. Material characterized measurement are also included in the calibrated point measurement category. Second one is special variation of field properties. These measurements are hydrophonic based and involve linear 1D and planar 2D mapping of pressure fields to a potential accuracy of 5 micro-m. This is particularly useful for determining transducer beam width and radiation area, but can also be used to determine the position of transducer site. Loops planar scanning can also be used to determine acoustic power when other methods are improved. Third one is whole field characterization. Measurement of total acoustic power within an amplitude and transducer efficiency can all be made with our radiation force balance. For medical transducer, tissue attenuated acoustic power can also be calculated. Hydro measurement of pressure, intensity, and associated measurement. Measurement of total acoustic power within aperture and transducer efficiency can all be made with our radiation force balance. For medical transducer, tissue attenuated acoustic power can also be calculated. This is our reference, and thank you for listening.